Hello and welcome to part 2 of solving quadratics by factoring. And so today we're going to look at the second part of solving quadratics. And let's see here, let's find my slide. And right here. Okay, so looking at example 3, we see that 4a squared plus a is equal to 0. Well, what we really need here is we need to get this into factored form, just like we had in the previous example where we had the factors x minus 3 is a factor and 2x plus 5 is a factor. This is in factored form. And what we need is to get this into factored form so we can find which values of a will make this equation equal to 0. So we're going to do that by starting factoring out the GCF. And the GCF here is a. So when I do that, I'm going to have a times the binomial 4a plus 1. Now, I can say that those two are factors that multiply to equal 0. So a is a factor and 4a plus 1 is a factor. So let's set them both equal to 0 because we know that either one of those or both of them are equal to 0. Well, it's pretty obvious here that a is equal to 0, but here, to find which value of a is equal, makes this equation true, let's start by subtracting 1 from both sides, and that's going to leave us with 4a equals negative 1, and then we're going to divide by 4 on both sides, and then that's going to leave us with a value of a equals negative 0.25. Remember, negative 1 divided by 4, not 4 divided by negative 1. Those are two very different answers. And so here we would say the solutions are 0 and a negative 0.25. Now, looking at example 4, again, we need to get this into factored form, and not only that, but we need to get it equal to 0. Just like all these other examples here where we had the equation was equal to 0, here the equation was equal to 0, so we need to get this equation also equal to 0. So to start that, let's go ahead and add 48 to both sides. On this side, the negative 48 and positive 48 are going to cancel out and can become 0. And that's going to leave us with x squared plus 48 equals negative 19x. Now let's go ahead and get rid of this negative 19x. We're going to add it to both sides. Here again, this becomes 0. And that's going to leave us with the trinomial of x squared plus 19x plus 48 is equal to 0. Now, the cool thing about this is now we can turn this into factored form by using our x marks the spot method. So that's where we have a times c at the top and b at the bottom. So in this case, we know that a times c is going to be 48 and the b is going to be 19. And the two factors that we're going to put here and here are going to be 16 and 3 because 16 times 3 is equal to 48. 16 plus 3 is equal to 19. So now we split up the b term into 16x and 3x. Notice that the x squared stayed the same and the 48 stayed the same. The 19x was replaced with 16x and 3x. Now we use factor by grouping to say what's the GCF of the first two terms, which in this case is going to be x, leaving us with x plus 16 inside parentheses. And then here, the GCF of these last two terms is going to be 3. And again, that leaves us with x plus 16 inside parentheses. So now the common binomial of x plus 16 factors out, and we're left with the second binomial of x plus 3. So now this equation's in factored form, and we can see that the two solutions are going to be x equals negative 3, which makes this parentheses equal to 0, and x equals negative 16. So again, the solutions are negative 16 and negative 3. Example 5, here we already have the equation really equal to 0. We can plug in 0 here for f of x, but this trinomial, we need to get it into factored form. And so again, we're going to start with the x marks the spot. We're going to take 2 times negative 21, because that's a times c, which is going to be negative 42. And then b is negative 1 on the bottom. The two factors that multiply are going to be negative 7 and positive 6 to multiply to negative 42 and add to give me negative 1. So now we're going to split up this negative 1x in the middle into negative 7x and positive 6x. So that's what I've done here. Now we're going to use factor by grouping to say the GCF of these first two terms is going to be x. So that leaves me with 2x minus 7. And here the GCF of the two terms is going to be 3. So factor out the 3. And that's going to give us 2x minus 7 in parentheses. Now the common binomial of 2x minus 7 factors out, and we're left with x plus 3 as the second binomial. And here we can solve this now. This is in factored form, and we can solve this by saying each of the parentheses can be equal to 0. Well, here on the right side, we know that x plus 3, that's going to be an easy solution. X equals negative 3 there. But over here, we're going to start solving this by adding 7 to both sides, which is going to give me 2x equals 7. And then we're going to divide by 2 on both sides. And that means that x equals 3.5. So the two solutions in this case should have been x equals 3.5 and x equals negative 3. Now looking at example 6, you see that this is already equal to 0, but it's not in factored form. So we're going to have to get it into factored form. And we're going to start here by factoring out a GCF of 3. And that's going to leave us with x squared plus 5x minus 6 inside parentheses. And then we're going to treat that trinomial inside the parentheses, and we're going to use x marks the spot. So at the top, a times c, which is negative 6, and at the bottom, it's going to be b, which is 5. So now we're going to we're going to label the factors here. 6 times negative 1 equals negative 6, and then negative 1 plus 6 is equal to 5. So now we're going to split up the b term into positive 6x and negative 1x. And here we're going to have the GCF of the first two terms, which is x, leaving us with x plus 6. The GCF of the second two terms, we're just going to factor out a negative 1 because we noticed that both of these are negative, and we need them both to be positive. So we're just going to factor out a negative 1. And now, completing the factoring process, x plus 6 times the quantity x minus 1. And that's in factored form now. And pretty easily, we can see that the solutions to this equation are going to be x equals negative 6 and x equals positive 1. One last comment here on number 6. This 3 of GCF that we factored out, since it's not doing anything, it's not got a variable to it, we can actually discard that after we have gotten this into factored form, because the 3 on the outside doesn't change anything. It's just a constant. Okay, so example 7, we look at this and we say, well, man, this is equal to 0, but it's not in factored form. So we notice that this is called a difference of squares. And so factoring that, we can turn it into x plus 2 and x minus 2. And then this is in factored form, and we can very quickly see that the solutions should be x equals 2 and x equals negative 2. And then lastly, example 8. Again, we see that this is already equal to, we can substitute in here 0 for y. And we need to turn this into factored form. So we're going to start with x marks the spot. A times c is equal to 7, and b is equal to 8. And the two factors that we're going to use are 1 and 7. That means that we're going to split 8x into 7x and 1x. Everything else stays the same. Now the GCF between the first two terms is just an x. So we're going to factor that out, leaving with x plus 7 inside parentheses. Here, there's GCF. We already know this is 1x plus 7. This is 1x plus 7. So we're just going to rewrite this one with a plus 1 at the outside, because everything has a GCF of 1. And so now we can see that the binomials that we get are x plus 7 and x plus 1. Now, this is in factored form, so we can say that the two solutions to this equation are x equals negative 7 and x equals negative 1. And that concludes our video lesson.